Okay, here is some help on the Math 3 3.1 task. This is a revisit of Scott's Macho March that was happening in Math 2, and what they wanted you to do in that task was basically go from the push-ups each day to find the total number of push-ups in the month. You found that this was a linear function, but adding the linear terms became, this over here became a quadratic function. So you can see 8 is 3 plus 5. And then 15 is that 8 right there plus 7. That's how they get 15. 24 is the previous term, 15 plus the new push-ups. So for this, it became a quadratic function. You were adding a linear term. Now they're going to push that up a notch, and you're going to go out to find function m of n. This is the total number of push-ups completed for the month. And so you're going to be doing much the same thing. They want you in this task to create the m of n column over here. So that's what you're going to do. I'm going to pause the video here in a second. You're going to answer questions 1 and 2 best you can. Make this column over here based on the description. Okay. Let's take a look at this other page. See, the push-ups completed for the month is m of n. But on each day, the push-ups completed, that's g of n, the column g of n on the other page. That's what you can answer these questions. When you get down to question 4, you're talking on day 4 for the month. See if you can figure out that from the table of data. When I get done with the pause here in a second, I'll show you all the answers to all these. You really should be able to do 1 through 4 on your own. 5 through 8 could be a little more challenging, but you have time to pause the video and try to answer it out. Okay, so let's go ahead and hit that pause button. Pause. Okay, let's get into the answers and do some explanations here. And I'll show you several pictures along the way. Here's the m of n column. Basically, this is adding the previous 2. See, 26 is adding that plus the previous 2. So you're adding the term before plus what he did on that day. 50 is the term before plus what he did on this day. And you're going to see the answer to the question down on number 6, 7, 8 here in a minute, that if this is a linear, the sum of linear terms is quadratic. If you add a linear term to a quadratic, you get a cubic. And that's what's going on. Here is a whole bunch of answers for the explicit and recursive functions. And this was done all, through one whole task, or a couple in Math 1 and Math 2. Again, recall the format for explicit and recursive functions. Okay. See the quadratic function? You're adding, that is a linear term. For the linear function in the recursive, you are adding a constant term. Let's take a look at the back answers real quick. So that answer is 15. This one's 24, straight off the column. And if you did the m of n column correctly, you got 50 right there. My guess is, for number 5, the answer is a cubic. So linear is an x, quadratic is x squared. I think this must be an x cubed. I think this must be a cubic because it has a higher rate of change. That's what's different for the explicit equation. And I think that's true. The higher the exponent, the higher the rate of change. And that is one of the big learning points getting away from this task. So a polynomial function of nth degree, it will model the sums of the n minus 1 degree terms. That's like I just said on the previous page. A linear is the sum of constant. See, that's n minus 1. Quadratic, that's 2, but n minus 2 is 1. So it's a sum of linear terms. Cubic is the sum of quadratic terms. And that's something we need to learn for this task right here. Two more pictures real quick. There is the textbook answer for the table. Take a look at that. And my table, when I worked this out years ago. Holy moly. And this picture is already up on Haiku, I think. See, there is quadratic. So I'm adding a quadratic term. Where can you see that? It's the first differences in m of n. This is a quadratic sequence. Here's the m of n. First difference is quadratic, second difference is linear, third difference is constant. That's how I know it's a cubic function. That's good stuff right there. This would take us a couple days to go through, which is why I'm making you do it at home.